Okay, this is Apologetics class number 9. And again, to just pick up on a few things where we left off last time, I wanted to just read you a couple quotes. This was the biology textbook I had in my undergraduate course in college, 1999, let's say. It was written in 96. And this author is talking about biogenesis, or the origin of life, or it's called abiogenesis, and talking about how the cell could have formed out of nothing, or out of the other materials that were on the early Earth surface. And so the author creates basically a story on how you could have arrived at the cell through natural causes. And so, again, this is on the early Earth, say, a few billion years ago, based on his age. And so I'll just read you this because it's very interesting. I think I brought it up a little bit last week. He says, obviously, though, we have not even begun to answer the question of how life came to be. It is indeed a long step from complex molecules to the simplest forms of life. Even the simplest living thing is composed of a fantastically ordered arrangement of complex molecules. How then could life have arisen from some ancient hot chemical soup? That's a good question, which is another way of saying we don't really know. Indeed, while there are no firm answers, we do have some ideas that bear mentioning. So you can hear in the author's voice that he's basically admitting to the idea that we don't really know how life arose on the Earth's surface way back then. And so he goes on to describe a very, very simplistic, not a cell, he calls it a droplet. And how this droplet could have been this coalescing of certain molecules or chemicals to form this kind of plasma membrane, if you will, around this droplet. Think of just a water droplet. And he said that would be considered a primitive version of the cell. Okay? And it really isn't. It is extremely simplistic, and it's not a primitive version of the cell. And then he goes on to make statements and phrases. I'll just kind of give you some quotes. He says, he uses the words, in a matter of 2 pages, he uses all of this wording. Conceptual leap, intellectual exercise. If we are to accept this, very open-ended kind of statements, healthy imagination, could have, would have, could have, would have, could begin, would be, would, this scenario, highly simplistic, basic scheme, we can speculate, could have, can, scenario, could have continued, would have been, would continue, would have, and according to this scenario, okay, and then so you get the idea. So the idea is that he's using a lot of wording to tell the reader, at a secular university, Cal Poly Pomona, okay, state university, that there is no firm evidence that we have for the rise of the cell on the early Earth surface. We have nothing firm. We have some experiments that show us what took place, maybe at this stage, maybe at that stage, and then he creates this narrative to bring all of this together, from a bunch of chemicals to a full functioning cell. And so by using healthy imagination, by using a basic scheme, by using, he says, use your own judgment to compare if cells organize are from organized droplets. So he's basically inviting the reader, the student, to get a glimpse at what could be the story of how the cell developed. But we can see by just his wording that there's nothing firm that he can present. And again, this is a state university's biology textbooks. The professor who used this was very anti-Christian. So there's a lot of things that were said in that class. I just remember being like, whoa, I can't believe we're talking about this. But so anyway, I want to just give you a glimpse at what is being taught at a secular college in the biology classroom. There's an admission to knowing that cells would not or may not have actually happened as they are describing. They recognize that this is just maybe a way to go about it, this basic speculation and imagination. And they do some experiments to show how these things, on certain steps of the way, give us a little bit of evidence. But in general, it is a lot of imagination and speculation. So even in that sense, we don't have anything firm on the cell's development out of physical necessity or chance, which were our two mechanisms, if you will, that we talked about the last couple weeks. And so that brings us to tonight. We have this topic of irreducible complexity. And if you look on your outline, on the it says 8th outline for today's day. Again, we're talking about premise 3, intelligent design is inferred as the most plausible explanation of scientific observations. And we talked a lot about specified complexity. Now we're talking about this concept of irreducible complexity, and we're not going to talk about it very long at all. So although we spent a couple weeks on specified complexity, we're only going to spend like 5 minutes on irreducible complexity. And the reason is because this topic is so highly contested and so highly argued in the public square, on the internet, in academia, that we don't want to use it as a lot of, we don't want to invest a lot of ourselves in it. And in your conversations on the street with people, you don't want to necessarily always bring this up and spend a lot of time on it. But it is extremely significant in the last, say, 20 years in terms of apologetics and the intelligent design argument. So this concept of irreducible complexity was first, I'm not going to really read through it all, but I'll just kind of give you the sense of what's happening here in these 4 pages. You can read it later. Irreducible complexity is this idea that if you have a bunch of parts, say of a machine, say of a car engine, a piston, a gear shaft, transmission, spark plugs, all of these things that are parts, if you put them together, you get a functioning machine. You get a whole that does something with all the parts in the right place. Now the parts have no meaning or have no purpose outside of that machine. In other words, if you have a piston and a gear shaft, transmission, and spark plugs sitting on the ground in a junkyard somewhere, they would basically have no purpose. They would just basically be a piece of steel rusting there. And so what Michael Behe, he's a biochemist at Lehigh University in Pennsylvania, did in 1996, he wrote this book called Darwin's Black Box. And this was really a groundbreaking book in terms of the ID movement, because he did such a good job in building this argument for this idea of irreducible complexity, which basically says that these parts of the molecular machine in the cell could not have arisen by natural causes, by Darwinian evolution, because the only reason why these parts in the cell exist is for a purpose of how they fit into this overall picture of this overall machine's mechanism. So Behe basically said that outside of the machine, these parts are worthless. They do nothing. Thus, there's no reason for them to have arisen through evolution, because evolution has the idea, obviously, of natural selection based on random variations in the genome. And unless this genome could show that these variations, these machine parts, if you will, have a survival advantage to them, then basically they would be, if someone could show that they have no survival advantage, then they should not have maintained over time. They should not have survived, if you will, if they have no survival advantage. And they wouldn't have a survival advantage unless they're in the machine. In other words, they can't just be sitting around in a junkyard, because that does nothing for anybody. They're just rusting, right? So in the machine only do these make sense. So you have to have the machine first. In other words, you have to have the design in mind, and then the parts go in the right place. So the way he puts this is, if you look at page 2 of 4, let's go back to Darwin for a second, in 1850s. In his book, Origin of Species, Darwin makes this very, very interesting statement. If you look at M down there at the bottom, near the bottom on page 2, Darwin's brilliant challenge to the skeptics was this: if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous, successive, slight modifications, my theory would absolutely break down. Okay, so Darwin is basically giving somebody in the future a way to show that his theory of evolution will not be true, or is invalid, or is not realistic, or does not correspond with reality. Darwin is basically saying, if anybody can show that a complex organ existed which could not possibly have been formed by numerous successive slight modifications, which is basically his theory of random mutations, my theory would absolutely break down. So how does one show Darwinism is false? Well, Behe took that challenge on. And basically, if you go to the next page, page 3 of 4, in his book, this is basically spelling out for you irreducible complexity, letter O there on page 3. In his book, Darwin's Black Box, Behe pointed out that the cell system is irreducible complex, which means that some system or machine of an organism is composed of parts which as a whole work together to perform a function. That is, that if those parts were taken away from the whole, they would have no purpose. And so he says in P there, the machines of the cell contain separate components needed for them to work. And Behe explains that these parts have no purpose outside their whole and would not have been a product of Darwinian evolution, as there would be no survival benefit for each part. So if you think of other things like a mousetrap, that's what Behe uses. He uses a mousetrap because it has a spring, it has the snapping piece, it has the board itself, it has other little components that would have no purpose outside of that machine of it being a mousetrap. Or if you think of a ballpoint pen, there's some spring there, there's the outside cylindrical part, there's the other stem part made of plastic or whatever that holds the ink. There's all these little features, there's the button at the top, that have no purpose outside of the ballpoint pen, which is for a purpose, right? It's been designed. So the same thing would be true perhaps of a light bulb even. Something as simplistic as a light bulb, which isn't necessarily a machine, but you have the outer shell, you have the aluminum bottom part that screws into the light bulb socket, you have the tungsten that goes across, and you have a few other components. All of those would have no purpose in their shape and in their form outside of the light bulb. And so Behe says that the cell is like a little tiny machine with all these little features and components that have no purpose outside of them being the machine of the cell. So in Darwin's time, Darwin just thought of the cell as this black box. And he had no ability to understand what was happening in the cell. So you know what a black box is, right? What is a black box when we hear that term used in common speech? What would be, what is a black box when someone's referring to that?
It's a container of information
of some sort.
You typically associate with
Yeah. So actually, that's what they actually call that little device in jets, the Boeings that we fly on. They call it a black box. When that France flight went down, do you remember that, over the Atlantic, coming from like Argentina to France or something a couple years ago? It just kind of exploded and came apart in midair. Everybody died, landed in the ocean, in the middle of the Atlantic. You hear about that in the middle of the night. Be afraid when you go fly. That could happen to you. No, I'm kidding. but this is really scary stuff, actually. I mean, if you think about it. But this black box actually went down, and they were able to retrieve it at the bottom of the Atlantic Ocean to find out what happened, because it had a script of the activities of the plane right before it exploded, and they could try to figure out what the captain was doing in the cockpit. And so it wasn't damaged, and they were able to extract information so that survivors' families kind of could understand what took place. Now, that's a little different. Usually when people talk about a black box, they just refer to like maybe a computer. They have no idea what's going on inside of it. It's just a black box. It's like all Greek to them. You know, it's some unknown thing, but it does a bunch of stuff. It has a bunch of information. So, and Behe called the cell Darwin's black box. It was this chunk of something that Darwin had no idea what it was. And so that's what this was. But it turns out that now we understand using X-ray crystallography that was developed in the 1960s and other techniques in understanding the cell, which is how Francis Crick and Watson were able to develop the double helix shape of the genome. They used these modern technologies so they could understand the cell. And so what was once unknown in Darwin's time now became known. And so Darwin never knew the complexity in the cell. He never knew there were little machines in there. He only thought it was a blob of gooey stuff. All he had was a microscope. And so what Behe did is he said, since 1960, Darwin's theory should have been thrown out, because we now know how complex the cell is. And so now if you go to page 4, and T, Behe argues that due to this irreducible complex systems that were not the result of a slow, gradual process of improvement, the prerequisite for Darwin's theory is destroyed. So what Darwin was relying upon is now gone. So Darwinism, he's saying, is basically should be thrown out. And this case was presented in Darwin's Black Box. I have the book back there. And it was just a breakthrough book. And it's still, 15 years later, being commented on and attacked. And the two leading researchers, I don't know if Behe is even a leading researcher. We may call him that now because he has given us such a breakthrough book. But the two leading researchers of the cell, in particular the bacteria flagellum, which is the tail of the bacteria in the cell, have attempted just recently to refute his book. So it's been 15 years and people have been coming out with all kinds of criticisms of his book. Because if Behe is right, then a lot of Darwinism is dismissed. And so it's a huge deal. And so people don't like this. So there's internet skeptics that blog about it all over the place. I mean, I haven't seen anything this disputed in probably any academic, probably any area of apologetics in general, as Behe's book. And so these two leading researchers just produced a paper or some journal article to refute this book. And just yesterday, there was a response, not by Behe, but someone from the Discovery Institute, where Stephen Meyer works in Seattle. And they responded for Behe. But Behe has tried his best in the last 15 years to provide responses. And I can't go into all of them here, and I can't give you all of the criticisms. It's just too much. I mean, it's just an ocean of this stuff on the web and in literature. And I think these two researchers wrote this, or either it's an article or a book, and it's called Irreducible Complexity Not, with the exclamation point. So I think that's the title if you want to look into it more. But again, there's tons of criticisms out there and responses by Behe. He has tried his hardest to respond to all this. And in the meantime, he's produced another big-time book that came out in 2007. And we'll talk about that later. Let's see, what else did I want to say about that? Let's read a quote here. W. Now, after the hard work of many scientists, there is no longer any reason to think that chance and natural selection explains the overwhelming appearance of design. The complex and elegant molecular machinery of the cell strongly proclaims its design. Now, in terms of machinery in the cell, do you guys remember the video from a couple weeks ago? The one I stole off the internet? Got in trouble for showing you that. Did you remember how it was the different proteins of the cell were kind of bringing things across the cell and dropping them off at certain places and doing weird things, and little globs were going in different places? Those are kind of the machines that he's talking about, but there's more to it that we didn't look at. But there's a lot of these machines, or processes, if you will. But some of them are actually machines, like this idea. What you'll find if you research this in Behe's work, you'll find he talks a lot about the bacteria flagellum. Now, what is a flagellum? What is that word? I've never heard it, right? Has anybody heard of this?
Is that
Okay, a few of us.
propeller?
Yes, the propeller. Okay, so you have this gear shaft, if you will. I'm not going to take a lot of time to draw this, but it's kind of say this is a bunch of proteins forming, and you have, say this is a three-dimensional sort of thing, and then coming out of it, there's some sort of tail, if you will. And Mark and I were talking about this, I think, last week after class. But the idea is that there's a bunch of like gears in here and other little shafts that at the end of the bacteria body, if you will, say that's the bacteria in the cell. So there's hundreds of these things. There's this whole structure here that really does look like a machine. If you were to go to some industrial factory or some plant, or maybe in the gear shaft of your car, that causes this thing to spin at an incredibly rapid rate. And it's been said that this is the most efficient motor known to mankind. And we can't devise anything as efficient as that in terms of the energy usage. So not to go into that too much, but this is the bacteria flagellum. And Behe, a lot of his book is about this. And so I just wanted to kind of introduce you to some of these terms and give you a kind of an understanding of how significant this is without spending a lot of time on it. But it's a big deal, and everybody like throws Behe out because of this. And they say that all of these machines that Behe's talking about could have arisen by natural causes. That there was some evolutionary benefit of each component of the machine. They could have been brought about by random mutation, natural selection, random variation, that sort of thing in the cell, which I totally reject, but these researchers are constantly trying to do this. And what Behe says about that, if you look back up to you, he says, neo-Darwinists attempt to explain the origin of these complex machines that are irreducibly complex by evolution and natural processes. Behe claims that these are quite unconvincing, and I think anyone with a modicum of skepticism will too. So Behe just rejects them outright, but he does know what they're talking about because he's been responding to this over the years. Now, people, again, attack Behe even as a person, saying that he's just trying to be the guy that refuted Darwin, and so he's the one that stays on this point for money-making purposes or whatever. And that's just not true. If you know the guy or whatever. Who knows people's motives, but if what he's saying is true, and all these things only make sense when they are put into a whole, then we have good evidence to soundly reject all origin of life schemes of the cell on the early Earth, because they could not have been arranged that way without the final purpose being known, the final position and function of those components being known. Are there any questions on that before we move on? Who here has a bit of background with this idea of irreducible complexity?
I'm not a term, but I mean, I understand that.
Okay. Okay. Yes?
How would it apply to the eyeball, to all the components of the eyeball?
Yeah.
How could they form visually?
Yeah. Yeah, the location of the retina. What's that?
Longer near field.
Okay. Yeah. I haven't heard that one before, but yeah, I can imagine. It was the bombardier beetle, some sort of bug.
Yeah, I said that, but what did she say? That the process of evolution was that it blown itself up at some point because of the mechanism.
Blown itself up.
So if it was blowing itself up, then it would survive. So we made it to the next.
If the evolutionary process is only part way and not fully.
Yes,
Oh,
the
okay.
process.
Got it.
It
Yeah.
wouldn't have been successful.
Yeah.
Thank you for clarifying that.
That's good. Yeah, so the final condition of the beetle must have been known in advance, and how it got there was most likely somebody put it there, maybe miraculously, but no natural causes could have produced it. And the same would be true for this. No natural causes could have produced, say, the machine in your car. Okay, so that's the idea. All right, so let's go ahead and get into the 9th outline. And again, this is all under the idea of biochemistry, in a sense. Now it's kind of into this biology. It's really not biochemistry anymore, but I put it in here because it fits the best in my overall line of reasoning. And again, for the new people, that's on the first outline, I think page 33 or 35. But we need to know what to make of this as Christians. We need to know how to understand evolutionary theory. What is it, and why is it important, and how should Christians deal with it? Okay, so who here has what they would call a decent background in understanding and remembering evolution? Okay, one. Maybe you. Our biology major? Okay. All right, so who here would like a quick overview of evolution, and who here would like to just jump to the criticisms? Raise your hand if you'd like a quick overview. Okay, we'll do a quick overview since 75% raised their hand. So if you can see there are these apes and men there in the picture, this is basically evolution. Now we're that guy naked typing on a computer, and we were that ape in the jungle over on the left. So that's just a realistic picture of what happened. We went from jungle, got some little hammer or knife in our hand, then a stick, then a rake for raking the leaves, domesticated, then we got to go to work, and now we're stuck in an office. So that's basically the history of mankind in a nutshell. So there's your overview. Does that help? No. Okay. All right. So here's the main issue, is that evolutionary theory has unresolved problems that show its limitations when explaining the development of life. And when we mean life, we're not talking about the cell. We mean, life today as we know it. Humans and animals and everything. Okay, so introduction. Charles Darwin, he basically says this: as natural selection works solely by and for the good of each being, all corporeal and mental endowments will tend to progress towards perfection. That's a big statement. Here's another little quote, but basically I'll summarize that for you by going to part 3. Evolution is a multi-part theory. It contains 3 components: common descent, which you've heard before, natural selection, and random mutation. These are the 3 main components of evolutionary theory. So when you talk about evolution on the street, you need to clarify what part of evolution you're talking about. If you say evolution should be thrown out because we couldn't have come from apes, then you're making a very simplistic, not so intellectual statement, and people will laugh at you. We need to have a little bit more sophisticated understanding of what evolutionary theory is as Christians. The last 2 could be considered the Darwinian mechanism. So when someone talks about the Darwinian mechanism, they're talking about natural selection and random mutation. Now, common descent is a different thing, and we're going to try to criticize all of those components with about 7 or 8 criticisms over the next week or so. We'll get to about 3 or 4 tonight. Now, the process of evolution in general, you could kind of define it as this. Evolution can be defined as a change in population through time. Now, that's a very broad and vague term. And so if you get a little technical, you could think of it as inherited variation in a population arises by meiosis, crossing over, and the chance combination of gametes. New alleles are added by mutation. So these are some biological terminology there, which probably not many of us are familiar with. But there's just a little snapshot of some words that you could use to describe it. But we could kind of simplify it even further by just saying this little scheme I'm presenting here, 3 through 9, if you will. Parental characteristics that are passed to the offspring are encoded in DNA molecules. So we've been talking about nucleotides and the sequence of them and how they carry information. And 4, the code is the source of the physical characteristics that gets passed down. Okay, so again, the code is important, like we've been talking about. And by the way, on page 2, if you didn't know this, your DNA is made of sterling silver and stainless steel. That's a joke, so don't think that. It's just some artist rendering. So on page 3, number 5 at the top, new different codes develop in this copying process. So when the offspring is being basically created, we have different codes that are imparting the information to the offspring. And that information, in number 6, leads to the different physical characteristics from parent to offspring. So the color of the eyes, the size of the nose, the strength of the bones, if you will, that sort of thing. Again, this difference is due to random variations in the copied DNA sequence between the original parent code to the offspring code. Okay? Now, here's a big statement that is often quoted by those who study evolutionary theory. Random variations give raw material for natural selection to act on. So when you have these random variations in the offspring, as generations come and go, there's these random traits, physical characteristics that obtain in the offspring that natural selection acts on. Okay, what do we mean natural selection acts on? Well, the process of natural selection can go to work on these random variations in the code, causing random variation in physical characteristics in the offspring, eventually morphing different creatures and allegedly revealing the process of common descent. So natural selection is this idea, it's kind of like gravity, it's this force, it's this physical necessity, if you will, that drives generations towards this goal of, as Darwin put it, perfection. And so what's left behind, or what becomes extinct, are those characteristics in those generations that did not have a survival advantage in that environment. They weren't able to adapt, if you will. So, the traits of the best reproducers tend to increase in the population. And what does that mean? So, when you have a cheetah, for instance, a cheetah is very fastest land animal, obviously, and one of my favorites as a kid. I love to just fascinate or philosophize about the cheetah and think about him and wish I was a cheetah, right? That's what you do when you're a little boy. You wish you're some sort of animal. So the cheetah, say there's a bunch of cheetahs that were born one year that happened to be extremely fast. Like, say, say they go about 70 miles an hour, and I don't know if the cheetah right now goes like 50 miles an hour or something. So they're just really fast. And all of those fast cheetahs, super fast cheetahs, get to the gazelles or the zebras faster than the ones that only go 50 miles an hour. So the ones that go 50 miles an hour don't have any food. They're hungry, they're starving, and they don't reproduce as often because all they think about is food. So they just die out quicker. They die of starvation, let's say. And the fast cheetahs, the ones that go 70 miles an hour, they survive. And those are the ones that keep reproducing. So over time, you have only super fast cheetahs left and not the normal cheetah. And let's say that those super fast cheetahs have some offspring, that go 90 miles an hour, okay? Well, eventually the 90 mile an hour cheetah gets all the food, and the 70 mile an hour cheetah doesn't, so the super, super fast cheetah eventually survives over the long term. This is the idea of natural selection, that there's a limited environmental supply of, say, oxygen or food or something or other, and the offspring that has the survival trait, that random characteristic, if you will, that lends itself to being more adaptable to that pressured environment will survive. And the offspring that doesn't have that survival trait will die off. And so this is kind of the idea. Now, it's not just by chance. A lot of Christians like to say that, oh, we came from monkeys by chance, you know, something like that. We use these very simplistic words and phrases. But when you're talking about macroevolution, and we'll distinguish that from micro in a second, we need to not say that we just came from monkeys by chance, or that's what the naturalists say. We can't really go there. We can't say it like that. Because the thing is that chance is only part of evolution. Evolution has those three components, right? So chance is only the component that deals with the random variations. So Darwinism is three components: common descent, and then random, let's do natural selection. So again, this is kind of more the physical necessity component. And then random variations. You can go back to that page. This is the chance component. So when we're talking about, when we say things like chance, we really are talking about this component of the whole theory in general. And this is the one that's more of like a physical necessity sort of thing, like we've been talking about the last few weeks. Now, when you put these together, you get this whole Darwinistic mechanism. And this is important because no biologist would say that evolution is all about chance. That's only half of the story. And that's what this little discussion is saying on page 11, or item 11 there. Let's see. What else? Now, let's read 12. It's a quote from a pretty interesting website. Down there at the bottom, I give you the footnote to where to go look for more of this stuff. This website has a lot of good information on misconceptions about evolution. So Christians would do well to go read this stuff because they clarify a lot of the bad, say, thoughts that Christians have, or the public has in general, about evolution. Now it says, if environment changes, variation is advantageous because it increases the chances that some individuals survive and reproduce, leaving offspring that also fare well under the new conditions, favoring certain phenotypes as the population conforms to new conditions. So again, variation is helpful in allowing populations to survive. So if we all, say all animals were to have just reproduced exactly how they were, then first of all, you wouldn't have the process of evolution because there's no random variation. But then as the environment changes or food supply becomes limited, then all that population would die out. There would be nothing left. And it's only the ones that have those traits that work well for the next environment, if you will, that's coming, then say the climate change that's coming, will survive long term.
Question. Looking at the evolutionary scale of human beings, according to evolutionists, that means that as a new species arrives that is superior to the preceding species, it will die out, right?
Yeah.
So how do you explain the chimp? It's supposed to be, if it's common descent, then that means the chimp is less superior than us. So
Yeah.
Evolution and natural selection would die out because
Yeah.
as humans would become superior.
Yeah, so when you're talking about, say, an ape ancestor of humanity. It's really a little bit more complicated. When the Darwinists or the evolutionists describe this, they would say that we are not from the ape species. We're not from the gorilla, the chimp, or anybody else. We're from an ape-like ancestor. So we're from the same ancestor that apes also have. So if you think of the evolutionary tree, it's kind of like that you have all these branches of animals, and say like we're this one, and humans, Homo sapiens, and then you have gorilla, and then you have, chimp, whatever. But notice that we all share the same ancestor. Okay, we'll call him ancestor Bob, let's say. Bob is the ancestor of the human and the gorilla and the chimp. We don't necessarily come from them. Okay, so that's to just clarify. So when you're saying climate change and environmental pressures should have caused the chimp to die out, well, not necessarily, because we're not necessarily the offspring, if you will, of them. We just are the offspring of him. Does that help? Yeah, so you can't really say that this should have died out because we're here. So, I mean, it's a good... I know what you're getting at there to try to use that as a criticism, but I don't think we can use that. Now, this whole idea of common descent, natural selection, random variations, when you add all these things together, you get this idea of macroevolution. Now, macro means big, obviously. Micro means small. But macroevolution refers to the idea of mutation, if you will. I like math, so I'm using math symbols. Mutation. And all of this happens over a long time. And that idea is known as gradualism. It's kind of this way to explain all of this in evolutionary terms, gradualism. So that is talked about there in item 13. So when you have macroevolution, you have species changing over time in such huge ways that you're going to arrive at an entirely different species when you give it enough time. Because you have these processes at work, chance and physical necessity, this double whammy, if you will, and then you're getting eventually a cheetah that's now, say, even bigger and stronger, and maybe the cheetah becomes larger than the lion, and then maybe even larger than the elephant over time. Or it becomes an elephant, This is the idea. It becomes an entirely different animal over time. And it has no direction to it. Like it's not eventually saying 5 million years from now, let's have our children, learn something and become an elephant. It's not doing that. It's just these indirected processes. But again, it's a natural process. That's the point. It's natural, but it's not directed. So now intelligent design would say, okay, well, let's grant evolutionary theory is true, macroevolution, and this mutation of animals over time. And let's just for the sake of argument grant that all this is true, regardless of these criticisms that we're going to present. Are these processes not undirected? Or do they need to be supplemented by design? Do they need to have a design component for us to get to mutation? The naturalist says, no, it's just this. And maybe if you're an evolutionary creationist or a theistic evolutionist, you would say it's this, and a design-directed process. So there's a little bit more to it than just this if you're an evolutionary creationist or a theistic evolutionist. So, but again, gradualism over time is the big issue. If you only have an early Earth, like the young Earth Christians say, the Earth is 6,000 to 10,000 years old, you don't have any time for all of these things to occur over millions and billions of generations of offspring. You only have 10,000 years. It's nothing. You can't get this. So the young Earth theory is very incompatible with evolutionary theory. An older theory is, but it doesn't mean you have to believe in evolution if you're an old Earther. There's other ways to go about it, which we'll get at the end of the class. Any questions on that? Okay, so what we'll do is we'll take a quick break, and I don't want to talk about item 14 just yet, but we'll take a quick break and then we'll start looking at the criticisms after the break, okay? We'll see you in 5 minutes. I have about 7 that I've been able to gather in my research over the years, 7 main criticisms of evolution. And a lot of times people talk about the origin of life on the early earth. It's already on, yeah. Thank you. They talk about the origin of life stuff and how the cell developed, and they call that evolution. But I wouldn't necessarily categorize biogenesis as evolution. I would just say it's its own thing. Origin of life stuff is origin of life stuff, and evolution is this, what we're talking about on the board here. Now, so these 7 or 8 criticisms I'm presenting are common criticisms. One of them has to do with the origin of life stuff, and that's criticism number 1 at the bottom of page 5. And all I'm doing here is I'm just saying that evolution usually doesn't pertain to the origin of life, as it has to do with reproduction, what happens after something is generating. And so when naturalistic causes are presented to explain the origin of life, it fails. That's what criticism number 1 is saying. Now, we already talked about that in the last couple weeks, so I'm not going to get into that again. But usually, if you're going to define evolution as referring to origin of life stuff, then the criticisms of the last couple weeks can be presented. But because we've already talked about it, I'm going to keep moving forward. And also, evolution, in my opinion, shouldn't include origin of life stuff, because origin of life stuff doesn't have to do with this. Now, before we do that, I have a big statement here in the middle of the page on 5, before we get to criticism number 2, which will be several pages long. But the big statement in the middle of page 5 has to do with 800 doctoral scientists who have signed a public statement proclaiming, "We are skeptical of the claims for the ability of random mutation and natural selection to account for the complexity of life." Now, the signers of this statement include scientists from all over the world. Russia, Poland, Czech Republic, India, and faculty at some of the most prestigious universities of our country for sure. So this is a growing campaign. It started off as like 100 scientists several years ago, but it's a growing campaign of scientists who are skeptical of these 3 components to explain the complexity of life. And so I think that is very important for us, because a lot of times the naturalists would present this statement that 99% of scientists hold to evolutionary theory. Well, depend on what someone means by evolutionary theory in general. Depends on the statistical source, and there's a growing number who are dismissive of it. So we need to keep that in mind when we're talking to people, because the descent of Darwinism is growing, and that's very important, because by appealing to authority, people advance their argument, So now, and also it depends on what these professors say. If it is 99%, what part of evolutionary theory do they hold to? Do they hold to this part, or this part, or all of it? Now, Behe himself, it's said that he may hold to common descent. I'm not so sure how that would work, but I think he would hold to that based on what I read. But I'm not quite sure, but it could be the case. Another geneticist who's an ID theorist, Michael Denton, apparently holds to common descent. But these things, they don't. So it's kind of like, well, if you're a secular scientist, what part of this do you hold to? If you're a Christian, what part of this do you hold to? So there's some room for confusion there. Now, criticism number 2. This has to do with macroevolution. So when we're criticizing evolution in this class, and if you're going to do it on the street, you want to criticize macroevolution. Okay? Now, the difference between macroevolution and microevolution is what? Can anybody explain it to us? Speed. No, not necessarily. But what do you mean by speed?
Well, I think it's a famous example of micro would be a certain moth and like
Yeah.
white versus gray.
Mhm.
With the pollution, the white ones were easy pickings for the birds or something.
Yeah, right.
The gray ones blended in, so that whole, there were no longer white ones because they used everyone.
Right.
That happens rapidly once the cold is started.
We're going to talk about that in like 1 minute. So I'm glad you brought that up. But now help me out. How does that differentiate?
Well, that specific to a particular environment,
Mhm.
versus, if that particular type of butterfly was in Mongolia where they didn't have cold plants, they changed.
Yeah. Okay. So an in-species variation.
Yeah.
Okay. Did you have a comment?
That's what I was going to say.
Okay.
I always heard microevolution is variation within a species, but macroevolution involves things over time actually changing into a different species.
Yeah, that's right. So again, micro is something that is changing in species. So Rachel had a baby recently. The baby has variations of you and Dave, and over time, the offspring could have, I don't know, say yellow eyes, say like 100 generations from now. Let's just throw something wild out there. But it's still a human, right? And the babies, 100 generations later could have feet, 3 times the size of what they are now, but it's still a human, right? So you're starting to see that even with drastic variations, you still have a human. And so microevolution is these in-species variations. Let's just leave it at that. In-species variations. Macroevolution is the entire change of an animal generation after generation into an entirely different animal. Like, a rhino and an elephant, something like that. Okay. So what you don't want to do is criticize microevolution, because microevolution is kind of a fact of the universe. We see it every day in our own offspring and over the generations of time. Now, this is the criticism. Is microevolution, what causes microevolution, the same thing that causes macroevolution? We're saying as a criticism, no. You cannot extrapolate from microevolution to macroevolution. So here's the criticism. Minor changes over time have not been seen to cause a new in-between species to emerge. That is, the evidence of macroevolution is unavailable. Thus, the process of natural selection based on random variations is not supported by scientific evidence. Now, that's a big criticism to throw out there, and I haven't really backed up where I'm coming from yet. But what is the response initially by the evolutionist? Okay, well, first let's look at this tree of life thing here. Now, you can see on the tree of life, I think this is even from Darwin's book, I'm not sure. But you could see on the tree of life that we're kind of near that ape creature up at the top. I don't know if it's a gorilla or what, but you can kind of see that common ancestor again is for us both, and we didn't really come from the ape. And then you have all these other things, and you may have seen stuff like this before. So I'm not going to spend a lot of time on it, but the idea of macroevolution is that from that protus at the very bottom, which is kind of like a very simplistic creature like a parasite or something like that, you're going to get all these variations eventually over time. And so from the whale, if you will, or some fish creature, you're going to get all these land animals and all these other things, and eventually us. And this is the idea of macroevolution. And it also shows this idea of common descent. Now, the response from the evolution is that we're claiming there's no scientific evidence of macroevolution. Like, no one sits here and sees, a human morph into, say, a alien or something, or an ape morph into a human. We don't see that in front of our eyes, right? Because we can't. There's not enough time. But we don't see any evidence of macroevolution. The only thing we see is microevolution. And we can see that very well in species that reproduce very fast. We can see changes over time in some of these, like rabbits, let's say. They reproduce quickly. We see variations and change over time. But with humans, we don't, and we just don't have any evidence for macroevolution. They point to the fossil record as evidence, and which we'll talk about as one of the criticisms in a second. But but that's not something we can see. So it's kind of indirect evidence, and we'll talk about that in a second. But they typically use about 3 or 4 ways to explain or show as evidence for macroevolution. They use these things that have been referred to as icons of evolution. And you can open up most biology textbooks and find them in there. This one does a pretty good job at being honest, even though it still is, it leads people astray. So it's misleading, this one, because of the way he words things. And he doesn't put in some of the icons of evolutions that have been dismissed. And some of these icons have been in biology textbooks for years, even back to 50 years ago. So, and they're still in there, even though they're radically bad in terms of evidence. So, icons of evolution include things like the peppered moths. These are icons of evolution that are brought up all the time in most textbook. The fruit flies in Hawaii. And then there's a whole bunch. The finch's beaks in the Galapagos Islands that Darwin visited in 1850. There's the Archaeopteryx. I can't remember the spelling of it, but it's a bird-like amphibian creature, kind of like the missing link. We'll get to it eventually. And there's a list of these things. I'm not going to list them all. But these are icons of evolution. And so people have just referred to these things blindly over the years to say these are pieces of evidence for macroevolution. And when you look at all these things, Mr. ID person, we have a compelling case that our theory is true. So icons of evolution have to do with these. And we're going to talk about these now. If you just fast forward to page 7 in item G, because a lot of this first part right here is just stuff we've already talked about before. Richard Dawkins and others claim that organisms develop from simple to complex, like you kind of see in that tree on the page before. With slow, gradual steps up a long staircase, one could easily climb an improbable mountain. So Dawkins, he wrote this book called Climbing Mount Improbable about 20 years ago. So if you're a person, say here's a cliff, if you're a person over here, and you're wondering how he's obviously much smaller. If it's let's say he's still small. Okay, let's say this is like 5 million feet high, okay? Super tall mountain, almost a cliff. How do you get up there? The ID person says that there's no way for a human to develop from a primitive species, okay, from the early Earth. It's too improbable, like we've been talking about. Well, Dawkins says, yeah, you're kind of right, it's extremely improbable, but it's highly probable if there is a bunch of switchbacks in the mountain and there's a bunch of stairs and he just starts going up the stairs step by step. And over about, 1 billion years, you can get to a human in terms of the evolutionary development. So if you start here and you're just this parasite, simple organism, eventually you could become a human over 1 billion years through climbing the mountain step by step. So in Climbing Mount Improbable, Richard Dawkins explains all this. Now, that's kind of what's happening here. And on the big quote at the bottom of the page and onto the next page, he basically starts describing that if you're a squirrel in the trees and you need to get to the other tree really quickly to catch the prey, it would help if you had a physical characteristic that would lend your body to have aerial flight advantages so you can get a little bit more air to get to the other tree. So if you're the squirrel and you get a running start and just so happen that you had a little extra arm flap here, that you would probably fly faster to that tree to get your food than your buddy who didn't. And say that guy reproduced and had some more offspring, and he had offspring that happened to have bigger flaps, and eventually that child flew faster and he got the prey quicker, or the food quicker than his buddy. Well, eventually, what would survive would be a flying squirrel, right? With that kind of an arm wing thing. So this is what is what's being described in this quote. And Dawkins is saying this kind of morphing is the advantage, and it shows that over thousands and millions of generations, you're going to have entire mutations of offspring in animals. Now, so this is kind of how you climb Mount Improbable if you're the macroevolutionist. And so what he does then is he talks about finch beaks, fruit flies, and the peppered moth, which is what you started talking about, Dan. And they give these examples of evidence of evolution. Now, this is a pretty good descriptive. It helps us. But what about evidence? Let's see if we can find some evidence. Well, let's take the peppered moth, for instance. The peppered moth, in item O there, I'll just summarize for you. Basically, the peppered moth was this little moth in England in about 1800-ish that was in the English countryside. And right around the time the Industrial Revolution happened and you had a bunch of factories and all this soot in the air that compiled in the atmosphere and came down on the trees, it started to land on these moths. And when the moths had all this black dust on them, they became more hidden with the tree that also had black dust on it. And so the moths that were flying around that didn't happen to have all this black dust on it, they were kind of still lighter colored moths, and the birds would eat those up faster because they would stick out on the tree. So if you're a darker colored moth, then you would survive longer because the birds want to eat you. You could reproduce, and eventually it said that these darker colored moths survived out and outlived the lighter colored moths. And so the darker ones reproduced, and eventually 98% of the moth population, I'm in item V on page 9, 98% of that population, 98% of the moths were darker ones, 2% were lighter colored ones. And so the evolutionists say this is an example of macroevolutionary change, that the change happened from white to dark, a complete change in color due to environmental pressures. Now, note that the white moths didn't actually become extinct as later regulation controlled soot pollution, and now the white and black moths are both apparently thriving in England. But according to the Darwinists, for this example, random changes in the genome caused minor changes in the kind of moth over time to the point where the original kinds were almost extinct and the newer, different kind thrived. So the idea is that environmental pressures caused the moth to morph over time. Now, what is the response when we hear these so-called evidences presented to help us climb Mount Improbable? Well, do you have any responses that stand out to you at the moment from this moth story? It's still a moth. Very good. Yeah, it's not a different moth. Yes? Yeah.
doing all right.
Yeah.
Just changing the calculation, like saying, well, there's blonde people in Norway, and then in China they all have dark hair. Well, it just depends on where you go to your distribution.
And they're still humans.
And they are humans regardless of
You have a point?
There wasn't really any change
Mm-hmm.
based upon the scenario,
Yeah.
except in popularity.
That's right. So you have eventually a growing bunch of moths that are darker. There's this many at one point and this many white ones, black and white. And eventually you had more of these, so you have a bigger population. And then this, is really small, so you have a tiny population. But it doesn't necessarily say that this became that, or that became that, right? So we don't even have in this example, that's a treasured icon of evolution, a mutation happening. You don't have that. You just have these reproducing more of themselves and these reproducing more of themselves. And what? Perfect question. Is this macroevolutionary change, or are we still talking about moths? These are all moths. There's nothing macro about this. This isn't a moth becoming a cheetah or a moth becoming a mosquito or something. You have a moth here, but you don't even have changes between them. So this example of evidence fails in many ways, but the two main ones is that there's no mutation happening, and even if there was, it would be micro. It's not macro. So those are the main criticisms of that. But this is hailed as evidence of evolution. This is why we call it an icon. It's something so sacred to the naturalist. It's like you walk into Catholic Church in Italy, like I've done many times, in these cathedrals, and you see all these icons that are worshipped, or not worshipped, but they're put there, and then people pray in front of them, and they're kind of these sacred little treasures, kind of like hobbies that we have here. We build these like little cars. If you're a guy that has a lot of hobbies, maybe build a bunch of cars and display them on your wall. This is what you find in these Italian churches, and I'm half Italian, so I have this kind of connection in my family's, a lot of Catholics, but so I have this oh yeah, I feel kind of at home here. I'm in Italy, I'm in a cathedral, Catholic lineage, all that stuff. But at the end of the day, I'm looking at this thing going, this is not as sacred as you think it is. There's candles all around it, stained glass, and they build these huge sculptures. This is that. This is the peppered moth. It is like everywhere. It's in this biology textbook too. Now, so that is kind of the response to the peppered moth. But in general, what we could say is that this typical response just describes and explains macroevolutionary theory as it gives alleged examples of the morphing species into others and an illustration of how this could be thought of to have occurred. So we have received explanations, clarifications, illustrations, and alleged examples, but we have not received evidence. So when they produce these as evidence of macroevolution, they're failing miserably. Miserably. Because this, we've talked about fails. The fruit flies is the same thing, where you have a fruit fly with 2 wings developing 4 wings. Again, that's microevolution, but there's problems with that, which we won't get into. The finch's beaks have the same issue. The thing that Darwin saw was that the beaks of on certain parts of the island of these finches were longer than others. And so he was able to understand that these islands are isolated. So over time, these finches just have a lot of changes. And so what was understood was that on those islands, there's droughts that come and go. And during times of droughts, the ones with the longer finch beaks, the longer beaks, could go get food in these nuts that were deeper. And there's a shortage of food. So those ones with the longer beaks survived. But one could also say that despite that being an example of microevolutionary change, it may not even be that at all, because it just so may have happened that Darwin came and left in such a short duration of time that he just saw this random variation of traits, and not necessarily due to surviving and environmental pressures. It just happened to be that at that time there's a bunch of ones with long beaks in this part of the island. and short beaks in this other part of the island. So it was very hard for him, I think, to get a full understanding of what was taking place on that island by his visits. There's other evidences that they present with regard to fossils, which are kind of 4 through whatever, that are kind of part of these icons. And we're going to get into the fossils here shortly, if we have enough time. Let's see. So these all have the same problems in terms of what is presented as evidence from macroevolution outside of the fossil record. Now, we talked about the peppered moth refutation already. And at the bottom on page 10, it doesn't stop the college biology textbook in front of me from incorrectly asserting the transition then from the light to the dark form was virtually completed in only 50 years. So it's so misleading, because then the student thinks, oh, well, there was this transition from light to dark. But obviously it just occurred like this. There's just less of these and more of those. So the biology textbook is extremely misleading. This is just one example of many, like I told you, where they present this case and make it fit to the evolutionary theory. Now, let's see. Let's see here. What do we want to say? Okay, now down to item J. It's what they try to do is they try to say, okay, well, we may not have very good evidence for macroevolution, but we have a lot of evidence for microevolution. And so they tell the ID proponent, you guys are crazy. Naturalistic causes, works no matter what. It's guaranteed to work and produce macroevolutionary change. The problem is that to extrapolate from microevolution to macroevolution, you need a lot of help, and they don't have it. They don't have any evidence, and they don't have any help in terms of biological experimentation. And so how do they justify their extrapolation? Well, they can't. That's the problem. They extrapolate from microevolution to macroevolution, and they have no justification. There's no warrant. And so in J, microevolution within a single kind is nothing considering the entire range of life on the planet. So in terms of the extrapolation, if they could show evidence that to explain the Darwinian mechanism produced the bat and it produced a whale, that would be very awesome. So if you look at this kind of big chart in front of you, when you think of a bat and a whale, you have all kinds of problems. Now this is kind of a very technical chart that biologists use to help graph and delineate between species. And so there's all these terms there in the middle. You can see Homo sapiens. If you look at RAB 21, there's Homo sapiens in there. Do you see that? Now that's just one of obviously many species here. So there's numbers and the way they categorize it with all these Latin terms. It's all worked out for you there. Now, you can't really tell what's happening, but to get from a bat to a whale, which is hard to see here, but if you go to the next page, it's much easier, because there's these cartoon animals. I got these off of the internet, and you can find them in textbooks all over the place. But you can see it's kind of a tree of life. If you look at the bottom, these stems kind of would converge down there, if you will. But it's kind of more zoomed in view of the tree of life. You see a lot more animals. And the bat is up at the top, and the whale, it's kind of like playing Where's Waldo here. If you could find the whale, I think it's at the bottom there. Tried to blow it up, but then the resolution didn't work out. But the idea here is that to go from a whale to a bat is a huge extrapolation. It's just mind-boggling. How can someone justify that macroevolution took place to cause that? I mean, just intuitively, it doesn't really make sense. You know, a whale is massive, lives in the ocean. A bat comes out at night, very small. So very, very different animals. So just consider that extrapolation, okay, as being like, wow, I can't believe you're willing to go there and say that this is how it all went down. But they do, with no evidence. Now, except for the fossil record, which we'll talk about later. Now, down at the bottom, but the bat and the whale are both mammals. Okay, so think of that extrapolation, but consider them to both be mammals. Okay, well, at least they're both mammals, so they have that in common. So this is trivial compared to a bat and a sponge. So if you look at the extrapolation of a bat and a sponge, it's even more monumental than the difference between a bat and a whale. So, and this is what the evolutionists would like us to believe, that the same processes produced the bat and the whale, no matter how different they are, and produced the sponge, which is a little tiny sea creature that's basically very primitive. Now, if you look at the page 14, you can see that up in the top right, the word animals and fungi and plants. Now, there's the slime molds and other weird things over there too. And so the sponge is in the area of, I think it's like a fungi or something else. I don't think it's even a plant or an animal. It's like something else. And so what we're told is to extrapolate everything in animals. See the word animals? That's supposed to say that out of that little stem of all these species that are on the planet, okay, think of the animal kingdom, how big it is. Well, now look at this and see the bacteria side, the archaea side, the eukarya side. I mean, if you think about it, there's tons more types of species on the planet besides just the living animal kingdom that we all know. There's all these other areas. And so they're saying just from that little animal stem came all of the animals on the entire planet. They extrapolate from simple creatures, from some simple primitive life form to get all of the animals, the sponge or the bat and the whale. But then to get a sponge, you're on this whole other stem here. So the point is that the extrapolation is extremely great when you go from a bat to a whale, but it's greater when you go from a bat to a sponge. It's like 10 times more of an extrapolation. And so that is extremely unjustifiable. Now, down there at O, William Lane Craig, he actually comments in on this, and he says this represents an entire leap of faith by the evolutionists. And so people then can criticize this to death, and they do. So we'll just say this last part in P. Regarding the illustrations by Dawkins, one asks, is Dawkins following the evidence wherever it leads and claiming that gradualism is actually what occurred in the alleged climbing of Mount Improbable by small steps up a staircase, or is he storytelling? So we have to differentiate between his fruit fly or his flying squirrel example that I didn't read but I quoted there for you, and this climbing Mount Improbable. These are narratives. These are descriptions. This isn't evidence. And these are not evidences either. At best, they could be evidence of microevolution. So with descriptions, illustrations, clarifications, teachings, things like this, they are presenting allegedly evidence. And we have to be able to step back and say, okay, is that evidence or is this a narrative? Are you describing how this tree of life could have produced the bat and the whale and us? Or are you describing it, or are you giving me evidence? And you're describing it. You're telling me a story. You're giving me a narrative. That's not evidence. So we have to take a step back and remember that. Now, there's a big quote I have here from Philip Johnson. At the very end on page 16 of the quote, I'll just read that. He says, until somebody fills the gaps with scientific papers rather than stories, meaning scientific research papers that go into the academic journals, the best explanation for this situation is that the staircase of Mount Improbable doesn't exist. So Dawkins' staircase to climb the backside of Mount Improbable doesn't exist, and no one is producing evidence for it in the scientific academic journals. So that's criticism number 2, and its responses by the evolutionists, and then the response from the ID proponent. We don't have time to get into criticism number 3, but that's okay. We'll have this next week and some others. But is there any questions on that? And then we'll close.
Just to make sure I'm understanding this right, some naturalists, there's a chart on page 14. In order to believe this to be true, they have to believe in both macro and micro, right? Because I don't see how this could just be,
Yeah.
they believe in both.
Yeah, definitely. Yeah, then
How they refuse, they have uses or faith in both.
well, everybody holds to microevolution. Christians, I mean, everybody. No one disputes that. Macroevolution is what the ID proponent disputes. And so what this tree and the other trees on these pages are representing is that there's huge gaps between species that we now see, and the naturalist says what best explains these gaps is that the in-betweens have died out, and all we're left with are what we see today. And we can see that through microevolution, we know that's true. Well, if that's true, then all macroevolution must be true because there's so many similarities between all the animals and other things. And so they try to build this case for macroevolution. And they have bad pieces of evidence, but we know microevolution is true because we see it all the time with our own offspring. But what the problem is they can't use microevolution and extrapolate to explain macroevolution. It doesn't work. It's too big of a jump. And that's the thing I was trying to show with bats and whales. The extrapolation from a bat to a whale is just monumental compared to small variations when we reproduce.
Does it, I'm going to say this right, does the difficulty of chance theory preclude evolutionary theorists from asserting anything other than a common ancestor? In other words, could there be multiple common ancestors resulting in variations in different species? Or is it just, I mean, what is commonly held by the evolutionary theorists, and are there those are offshoots and alternatives to that?
So the question is it possible that there's a bunch of different common ancestors to, say, humans or other species instead of one common ancestor?
Yeah.
Okay, so there's two views on common descent, if you remember the three components of evolution. There's universal common descent, and then there's just common descent. Universal common descent says that we all came from one creature. At the earliest times, we're from one, say, simple life form. That's universal common descent. Common descent just says, well, we could have all came from similar primitive, simple life forms. And so the tree would look kind of like this. You know, you'd have, one kind of trunk, and then you'd have another tree with other trunks, and then maybe we're like over here. That's how we got here. And then there's like other trunks, if you will, and then there's other animals. So these don't necessarily converge. Universal common descent says that these would all converge there into one life form.
What is most popular,
I think more and more people are going to common descent, not universal common descent. And that's due to the fossil record and other things, which we'll get into. And we're going to talk, and this is kind of this idea of convergence and divergence when biologists talk about this. And it's like, well, suppose this originated in South America and this in Africa, but you're going to get like a lizard in Africa that looks like a lizard in South America, or say a bear in Russia and a bear in, I don't know, North America. Something like that. They may look alike because of environmental pressures. And so eventually you're going to get a similar looking bear because they live in similar climates in a similar forest or something. That's the idea of, say, convergent evolution. But then you have to talk about populations, how they moved across the earth in earlier times and things like that. Yeah.
how can there even be common descent?
That's regular common descent, not universal common descent, go against the whole idea of one cell. Am I mixing two less than better? If everything comes from the one cell, right? Then shouldn't it just be one common ancestor?
Not necessarily, because if you remember that prebiotic soup we talked about, and then say it's oceans vast and tons of chemicals are in it, let's assume that it existed, for instance, because there's problems with the whole idea of a prebiotic soup. But let's say it existed and you have oceans of chemicals. Well, then the same sort of processes that produced the one single-celled amoeba could produce billions of other of those single-celled amoebas. And those single-celled amoebas could have reproduced, let's say, and gradually developed better, bigger molecules, and then became, say, a sponge, or became, say, a lizard, you know. And so you could have gotten from different cells, you know, the different, if say they're not converging, you could have got from one cell this bunch of animals, from another cell this bunch of animals, and another one that. And so if you have billions of cells, then you can kind of easily explain all these different trees of life, if you will.
So I was picturing it that God soup creates one cell, and then from there, cells are all
Yeah.
multiple prebiotic soups
Yeah.
create cells, and say there's things that prebiotic soups in the whole different
Planet of the on the planet. Yeah, they could have created tons of different animal species depending on what sort of energy or like chemical reactions were happening in that prebiotic soup area. But we talked about that last week of having tons of problems. The chance can't explain it. Physical necessity can't explain it. So we still have the question of where did the life come from and the information come from. Yes, sir.
So, what's like the, I guess, delineation or just kind of like the ideas between adaptation and microevolution? Like when is something adapting versus like all the time evolution?
So the question is, when could we say that an adaptation and mutation took place, like a macroevolutionary mutation, versus just a microevolutionary change within the species?
When would you like say, like when would you call a creature adapting to an environment, just becoming more specific or getting better at surviving in that environment, versus applying the term microevolution? Are they interchangeable or?
Not kinda. I mean, the macroevolutionary theory says that these changes in the genome and the offspring create a species that is more adaptable to that pressured environment, so it survives longer. So, in other words, a microevolutionary change will produce a better species for that different environment that's coming. And then over time, you're going to get that macroevolutionary change. So in the sense that they're kind of using microevolution to explain macroevolution. I don't know if that answers your question. Yeah. Okay. Help me out.
Well, you just said that the micro or adaptation could be macro. It wouldn't necessarily. You could have some sort of environment or some sort of variable mutation that would prohibit its further longevity.
Yeah, so right. So then you have a negative, so you could have species that go extinct, which we have seen. If your random trait that you inherit from your parent is not helpful for that oncoming environmental pressure, then you would go extinct, is the idea.
Careful about being prideful of your mutation.
Yeah. Pride.
Improvement may be tomorrow's.
Oh, well said. Yes. Very good. Yeah, exactly. So don't get excited about evolving this week, okay? Bad things may come. All right. Well, let's close. And if you have any other questions, I'll be up here. Dear God, thank you so much for this time to contemplate all this, and thank you for this smaller class tonight that we could have just a more informal time together. And we just pray that you would bless this week for us and let us understand how you design the world more and hopefully we can understand you better, and that could help our relationship with you and enhance our worship. Thank you, God, for all that you've given us, and help us get home safely, and bless us this week. In Jesus' name, amen. All right, thank you, and you're dismissed. I'll be up here.